Hello friends, welcome to Data Science Lovers. In our last video, we learned about the random module. In this video, we will learn about the Linspace function. So let's start. The Linspace function in numpy returns the evenly or you can say linearly spaced value within a given interval. Maybe this statement is not clear to you as of now, but it will be clear later. This is a simple syntax to use the Linspace function. First of all, we have to use our numpy library. Then we have to use the linspace function. And inside this linspace function, we have different parameters. First one is start value. Second is stop value. Then we have number or you can say num. And we have the endpoint parameter, reg step and data type, which is denoted by d type. In short, here one thing you have to note that by default, the linspace function shows 50 values. It will be clear later to you. As it is a part of numpy library, first of all we will import the numpy library in this Jupyter notebook, and the syntax is import numpy as np. Now I will use linspace function. As per this syntax, we have to use numpy library np dot linspace. Our first parameter is start value. Suppose I give a start value of 2. Next parameter is stop value. I will give a stop value, suppose 20. Third parameter is number. Number means how many numbers we want in our output. Suppose I give number equal to 10, means I need 10 numbers in my output. I will save this in a variable name a for my reference. You can give any variable name to this. If I run this, the command has been successfully executed. Now let's see what is gives in output when I print a. The output is this. Here if you see that the start value is 2 here as we mentioned here, and the stop value is 20 as mentioned here, and all the 10 numbers are linearly distributed between these two values that we passed in the linspace function. It means that between every two numbers, first and second, second and third, third and fourth, the difference is equal. Here you can see there is a difference of 2 between every two numbers. 10 to 12 there is a difference of 2, and 18 to 20 there is also a difference of 2. Okay, our next parameter is endpoint. Let's see how to use this. I will copy this or I will write it again. np dot linspace. Our start value 2, our end value 20, and number again I will pass 10, and this time I will use another parameter endpoint equal to false. I will save this again in a variable name a. Now if I print a, you can see that 20, which is our endpoint or you can say the stop value, is not in this sequence or in this output. Why? Because we have given the endpoint equal to false. Means we don't want to show or we don't want to generate the endpoint in our output. Now what will happen if I pass endpoint equal to true? Let's see. I will copy the syntax and paste here, and this time I will pass endpoint equal to true. If I run this and if we see the output of A, then you can see this time the end value 20 is also showing here. It means the endpoint is true by default in this linspace function. If we don't want to show the stop value or the last value, we can pass endpoint equal to false. Okay, this is the difference between true and false for endpoint. Next parameter we have is reg step. Let's see how it works. I will again use linspace function. My start value 2, my stop value 20, number I will pass again 10, and endpoint equal to true, which is already true by default, but I will pass for your reference here, and this time I will pass a parameter ret step as true. Save this in a variable name a, small a, and if I print this a, then you can see there is additional value here, which is 2. This 2 is the step value between every two values of this sequence. If you see here, the difference between first value and the second value is 2. Similarly, the difference between the second value and third value is 2. And 2 is the step value, or you can say difference between every two values. So this is the ret step. When I give ret step equal to true, it is showing the step value, and when I pass ret step equal to false and we print again a, then it will not show the step value of 2. And also notice one thing here, the output when we use ret step equal to true is shown in the form of a tuple, which is denoted by these two round brackets, and when we put ret step equal to false, the output is in the form of a 1D array. Okay, moving to our last parameter, which is d type or data type. I will copy this, and if I paste here, and this time I will use the another parameter d type equal to int, or you can say integer. I will run this, and when I print a, you can see all the values are now in integer format. Earlier by default all the values were in float format 2.4.6. Now the all values are in integer format 246. So we can change the data type of our values in the output. We can also pass the data type as a string if we want to use anywhere, like this print a. Then it will convert all the values in the form of a string, and if you notice, it is denoted by these quotes around each value. Now one note was mentioned here. By default the Linspace function shows 50 value. What does it mean? Suppose I copy this syntax, or I will write it again here, np dot linspace. We will pass our start value as 2 and our end value as 20. Save this in a variable name a, run this and print a. When I print this, then you can see it is showing 50 values between 2 and 20. Our start value is 2 and our last value or end value is 20, and between these two values there are total 48 values more, and in total there are 50 values. So this is the meaning of this note. By default it shows 50 values. When we pass here this parameter num or number and give any value to it, then it will show only the specified count of the values. Here we haven't passed the parameter num, so it is showing 50 values by default. If I pass num equal to suppose 24 and run this, and if I print a, then it will show 24 values between 2 and 20, and all values are linearly distributed. Okay, and if I want to check that what is the step value between these two values, then I can use the parameter that is step equal to true. If I run this, then you can see the step value between every two value is this 0.78260. So that's how we can use the Linspace function in numpy